The final thing we need is how to do inner product. How do we multiply matrices and vectors together? The trick is to keep track of the dimensions. So you want to multiply this matrix A with the price vector. So in this case, we have a 5 by 3 matrix. This is a 5 by 3. And we want to multiply that with a 5 by 1 vector. So the idea is now, what is the value of each holding? Not the number of shares, but how much value do each of these funds hold of each asset? So we just need to multiply the number of shares with the price of that asset to get the value that the fund is holding. So we want to multiply the A with the price. So I'm going to name this vector as price. However, if I try to do this multiplication, then I'm going to try to multiply a 5 by 3 matrix with a 5 by 1 vector. The issue now is that these inner products are different. 3 and 5 do not match, which means that this calculation will not work. So I need to make these dimensions match somehow. So maybe I can take the transpose of A and multiply it with the price that way. Then the dimension would be a 3 by 5 and a 5 by 1. So now the inner dimensions matches. However, the outer dimension will be a 3 by 1. So this will be output a 3 by 1 vector. However, we want a row vector, not a column vector. So we want something that is outputting a 1 by 3 vector. So this means that this doesn't work either. So what we can do instead is like switch the positions. So we take the price, we transpose it, and then we multiply it with the A matrix. If we do that, we're going to get a transpose of the price vector, which means this is a 1 by 5. We want to multiply it with the A vector, which is a 5 by 3, which means that the inner dimensions matches, and the output is going to be a 1 by 3 vector, which means that this is probably what we're looking for. And this is why I'm always emphasizing that just keep track of the dimensions. So even if you don't remember how to make the inner product, if you just keep track of the dimensions, so you know that the inner dimensions matches, and you know that you get the output dimensions you want, then the software will take care of the rest. So once again, in Excel we need to know exactly the output size. So I'm going to highlight this 1 by 3 vector. And then I know I want to take the price vector, this one, but I want to transpose it. So transpose. And once again, if you're using a different language, you're going to use a different name for this function. So I take the transpose of the price vector. And then I want to multiply it with this matrix. And to multiply matrices together in Excel, we have a command called mmult, which is a matrix product of 2 arrays. So I'm going to double click that one. And now once again, depending on which version you have, the exact way you feed this in will be different. So in my case, I feed in the first object, the transpose of the price vector. And then when I separate now, I'm going to use a semicolon. But I know that if you have an English region, you're going to have a comma here instead of a semicolon. So you just need to read the instruction here. What symbol do you have between these 2 arrays? And use that one. And then the second array is the A, or I can just highlight it here instead. Close down with the final parenthesis, and then remember, Control Shift Enter to get the output. Okay, so this is how you do it with linear algebra. So if you're working in R, MATLAB, Python, this is how you're going to do it. However, there you can just write the command and it's going to be very quick and very simple. I would recommend that when you work in Excel, you skip the cell arrays and just set it up in the Excel way. So what we want to know is actually how much value is it in these shares. So I want to multiply the number of shares with the price. So I just write equal sign, highlight number of shares, multiply it with the price, and then I get the value of those shares. Now in Excel I need to just think, okay, if I pull this down, then I want the price to go down and I want the number of shares to go down. So this seems okay, so I can just pull this down. And then if I pull to the right, I'm gonna run into issues because this one will try to multiply with the H column. So that won't work. So then we might remember that in Excel, we can lock down the columns or rows by using a $sign. So I want this G column to be fixed. So I put a $sign in front of the G, and then it will not move when I try to pull it around. So when I pull down, it should change the values. So this should be this one times this one. Okay, great. And then if I pull it to the right, oops, sorry. If I pull it to the right, then we should get the next fund times the stock price. Great. And then we should get the final fund times the stock price. Great. So these are just the value of each asset that each fund is holding. So I'm just going to copy the names so we get a very neat output here. And then finally I need to sum up each of these columns. So I'm going to go on the formulas and then just sum it up. You can also click here and click sum to know exactly what you're going to get. Just double check, did it highlight the correct things? Yes, I push enter, and then I'm just going to pull this out to the right. Now I got some strange formatting on my numbers, so I'm just going to highlight it all, right click, format cells, and then I'm going to make this into a number with 0 decimals. And if everything went correct, these numbers should be the same as we did with the linear algebra. And they look the same. Yay! We finally did it with Excel. So notice here, doing it the Excel way is pretty much as quick as doing it with linear algebra in Excel. And that's why when you want to use linear algebra in Excel, it's a strong sign that you should switch software. Because what happens now if we add an additional asset here? Then we need to actually redo all the calculations because you need to highlight the correct number of cells, which means it's the same work as just fixing it the Excel way. So that's a big difference with Excel and the statistical softwares, is that linear algebra, you do not want to do that in Excel really.